What is going on, everybody, and welcome to a bit of an R&D video with OpenAssistant's Pythia 12B or 12 billion parameter model. This is a model that you can run completely locally. You can download the weights and use it however you please. It's been trained with OpenAssistants through RLHF, or reinforcement learning through human feedback, and in my experience, it's a pretty solid model. You still might need, if you have a particular task you're trying to get it to do for you, you might need to do a few shot learning in the prompt before you get to what you're trying to do. But overall, I'd say it's quite a solid model, and I definitely recommend checking it out. So anyways, with that, let's go ahead and begin working with it. So the first thing I'm going to do is go ahead and touch, and we'll just call this basic OpenAssistant.py, and we will open that in lovely VS Code. We will also make it nice and big. Okay, so to start, what we're going to do is I'm going to import actually, what we're going to do is from transformers, we're going to import auto tokenizer, and then auto model for casual, auto model for casual language model. Cool. We don't update in the syntax house. Anyways, then we're going to import torch, yes sir, and then we're going to import OS. You don't necessarily have to import OS for what I'm going to do, but basically because this model, it requires either 24 gigabytes of memory at half precision or 48 gigs at full precision, so 32-bit float. The problem is, even if you have a 24 gigabyte graphics card, let's say, you still are not going to be able to fit it if that's also your main GPU that powers like your desktop environment. You're not going to have enough. You need truly every little bit. And then even if you're using it as a dedicated card, I have found at half precision, it still can overflow. So keep that in mind if you intend to use it. So first things first, we are going to specify our model name. And in our case, let me actually pull it up. So if we go to Hugging Face, we can just type, I guess I'll just do OAST. Yeah, and this is the one that we're looking for. And keep in mind that as time goes on, there might be a more recent version. So this one, I started, tinkering and playing with this model when it was the first iteration, and we're already up to the 4th iteration. So it's been out for like a month or so. so anyway, maybe a couple months. I don't know. Time is flying lately for me. So anyway, this is the one that we want. So I'm going to go ahead and copy that path, and I'm going to paste it in here. So that's the model name that I want to use. Then I also am going to say environ. And in this case, I don't want that. What I want to do is CUDA, thank you, visible devices. So this is where you can set the index of your GPU to be visible for this script. So for example, if you had multiple GPUs, I think in my case, 0 is going to be, I'm actually not even sure. I think it's probably a 3090, but I can't even remember now. Anyways, that should be fine. Actually, I might change that. I'm going to go to 2 because 2 is at least for me, we'll have plenty of memory on that one. So, okay. So anyways, if you need to do that, do that. If you are just running it on CPU and RAM, that's totally fine. Then no worries. So then I guess, sure, that we can take that line. Tokenizer equals auto tokenizer from pre-trained. So we're loading in the tokenizer, and then we also need to load in the model from pre-trained model. And then, okay, so we'll take that line, and I'm actually going to remove the .CUDA. And the reason why is I want to run this at a half precision. Another reason you might want to run at half precision is just for speed. So it's going to be considerably faster at half precision. So you can do either one. But if you definitely are running it purely because you can't fit it, but you can fit it in like CPU and RAM, but you can't fit it on your GPU, the first thing you're going to really need to do or want to do is going to be model equals model, and then first cut it in half or run it at half precision, and then send it to your GPU. So that's what we're going to do. Next, we're going to specify some input. So this will be our input string, and we're going to say what color is the sky. For example, that might be some of your input. Now, one thing to keep in mind is, and we'll get to it soon. Where is my browser? This model has the following special tokens. It has prompter, assistant, and then end of text, and that is used, end of text happens to be at every end of turn, so to speak. So I guess it's sort of a valid use case. So I've never seen that token used that way. So if you're used to always just like truly the end of the sequence generation being end of text, take that into account. So for example, you'll have prompter, what does it mean, blah, blah, blah. But then at the end of that prompt, you'll have end of text, and then you'll have the actual kind of like coaxing and the prompting of, hey, now return the assistance response. You'll have a tag, you'll have something coming after end of text. So keep that in mind. Anyways, so we could pass a string like this, and it should probably actually still work. But keep in mind that you're actually going to probably be wanting to use these tokens. Now we'll use those shortly, but I just want to show a really quick basic example of working with this model, and then we're going to continue building on top of that. So no worries, we will get there. So once you have some input string, we are going to do input IDs. That is going to be correct. Yep, that's everything we want to do. Thank you, Copilot. So input IDs, we encode with the tokenizer. We pass the input. We do want to return PyTorch tensors, and then we're going to send that to the GPU. We send that to the GPU because that is where our model is. If you're not running your model on the GPU, don't send your tokens to the GPU. So once we've done that, we are ready to actually generate. Now, again, if you were just running this in CPU and RAM, you probably actually could get away with what it's suggesting me to do. Just do a quick model generate. But if you're running on the GPU, what you're going to want to say is with torch.cuda.amp, that stands for automatic mixed precision, we are going to autocast. And autocast is automatically casting the data type for things. So like float 16, 32, all that kind of stuff. It's just going to automatically do that for us. The output now, that's close to what I want, but I think I'll take that, and I'm just going to remove this. Max length, I think 100 is a bit short. I think eventually you probably should set your max length to the true max length, which is 2048 for this model, if you didn't know, which is actually a pretty substantial context size. Usually it's like 1024, and so 2048 is really nice. I wish we had like an 8K context model, and I'm looking very much forward to open source models with gigantic context. So if you're someone working in that space, or you're aware of some project working in that space, let me know. So anyways, I'm going to set max length to 256. Do sample, this is whether or not you want to do random or greedy sampling. So in this case, we'll allow for random sampling. It'll give us a more variety in our responses, but you could also set that to false if you want. Then the other thing, well, we're going to add a couple more things. So first of all, we're going to add early underscore stopping, and I'm going to say that is equal to true, and then we are going to say the end of string token ID is equal to model, and you can just dynamically grab this for each model. So model.config.eos token underscore ID is what we're looking for. Let me make sure that it actually did what I wanted it to. Yes, it did, and then it also finished. It really wants me to throw in those other parameters. Number return sequence. Didn't we already do that or no? Oh, maybe I already had that or something. I don't know. Anyways, maybe I'm confusing myself. And number of return sequences. That's fine. Let me go ahead and close this off, and I think we're good. That was a little messy there. I started running out of space as I was recording, so it like interrupted my thought process here. I'm trying to think if there's anything else I haven't like mentioned here. So early stopping equals true just means if we hit a stop token, it will stop generating. It's kind of save us processing time, because otherwise in the logic we're going to trim off any extra anyways. So there's multiple ways that we can handle for that. So in our case, we're trying to make this into a chat model. So let me pull it back up, the example that it had. Yeah, so in this case, you know, this might be your input to the model, right? You got prompter. What is a meme? What's the history? Blah, blah, blah. And then you'll hit compute. Let's, oh, is it going to error? But tokens, okay, well, I don't know. Anyways, you'll see example in a minute anyways. But it's just going to continue generating a response. That's all these generative models do. They just have some input context, and then they just generate they just continue generating. In this case, it's going to generate an assistant-like response because you've prompted it that, hey, we've got prompter, now we're asking for an assistant, please, and it's just going to continue generating. But the thing is, after it's done generating an assistance response, it's going to probably, almost certainly, generate a prompter token and then generate what it thinks might be a good next prompt, you know? So in general, if you're trying to make it into an actual chatbot, what you're going to want to do is like stop the response at the end of the assistance response. So that's what we're doing with this kind of like early stopping. Once we get to end of text or end of sentence or whatever, see, EOS is usually end of string, I guess, and in our case we're calling it end of text or something, but anyways, we will do that. We'll just stop there, and it saves a lot of processing, and then we're just going to return one sequence. We don't want to have a list of them to choose from. So okay, so I think that's all we need. Once we have our output, we will come down here, and what we're going to do now is output equals output dot CPU. So we're going to send the output, because right now it's on the GPU. We're going to send it to the CPU. And then finally, we are going to decode it. So we're going to say output underscore text equals tokenizer and dot decode output. We're going to grab the 0th. We only returned one element anyways, but we're just going to grab it, that specific one. And then skip special tokens. If you are using Copilot, this is going to annoy you with these models. In our case, I want that set to false. And what that's going to do is it's going to take those special tokens of assistant and prompter and end of sentence, or end of text rather, and it will just ignore them. It won't show them in the output, which is convenient in some scenarios, I suppose. But in our case, we actually want those because we want to handle for them in our logic. So we have output text, and then now what we're going to do is print that output text. And finally, we are ready to run our very first example. All right, so I will open this up. I always forget on this machine. I think Python 3. Yeah, okay. Python 3, what was it? Basic OASST. So on first running, this might actually take a considerable amount of time because you might have to actually download the model first, and then you'll be able to run it. So it could take, yeah, I don't know, 10, 15 minutes. Otherwise, it should take about a minute or so to load it in. So I can just open up a few things here, and we can watch it load in together. So I don't know what my starting memory was, but you should see about 48 gigs of memory load in initially, because we won't run it at half until we can load it fully and then cut it in half essentially. So we're just going to kind of wait on that, I guess. So I'm guessing we're at least getting close. It looks like it's chopping that model. It just chopped the model in half. And then we can see it loading up the model onto the RTX 8000 here. Looks like it's already actually processing at the moment for a response, I assume. Possibly. Looks like it's still loading up. The response time on a GPU should be about a second or so. So I guess we're just still waiting. I'm going to move HTOP out of the way now. Okay, so what color is the sky? So in this case, it actually didn't give us a assistant-like response. It actually looks like it tried to produce a multiple choice exam of sorts or something. And the reason for this is we didn't use the tag, so it was not clear to the model, I think, that it was supposed to answer that question. So for example, I guess I could break it. I'll just keep cutting out the loading time. So for example, it's just going to continue that generation, because that's all generative models do. They just continue some sort of sequence. So it's no surprise it didn't answer that question. So to get it to answer that question, if I can ever open back up, thank you. I probably look really weird, like trying to open up various things. Anyways, so what we're going to do now is we're going to use the tags that we're supposed to use. So if we use prompter, and then end of text, and then assistant, like that, and we save that, and then we rerun that. Now we got to load that all the way back up into memory again, cut it in half, put it onto the GPU. And this is why the next step that we're going to do is actually build our own API. Now, there are a couple things that people might say is like, oh, well, you could use a Jupyter notebook or something like that. And you can. So you could load it in your notebook and then do all your like R&D and stuff. But chances are you're probably trying, if you're using models like this, you're probably trying to use them and access them on things like Raspberry Pis or other machines entirely. You're not always going to want to be in a notebook environment. So instead, I think the best way to like do R&D with these models is to just host them locally as an API service just to yourself. so that's what I've been doing with these models myself. And so I decided to finally just go ahead and share with you guys the process I go through to do that. And in fact, because this is, I can't remember if I'm actually on my GPU for recording or not, but I think we'll be fine. I think while we wait for the response on here, we actually could begin building the API. So let me move that. And, oops, not a folder. Open in terminal. And let's call this touch OpenAssistant API.py. And I'll just close that, and we will open in Visual Code. I'm trying to decide where I want to put this. I just want to make it smaller and put it on a different. There we go. I'll try to remember to pull that up when it's done. Okay, so now what we want to do is build our. Oh, it's actually done. Okay, coming back. So in this case, you can see. Okay, so this was our input prompt, and then we stopped at assistant, and then as you can see, it just responds blue, and then end of text. And again, it stopped there because we told it, hey, stop at those inputs. Because at this point, you would conceivably show that, and then you would just be waiting for another input from a user to ask another question or a follow-up question, and so on. So, okay, cool. So moving that aside, now what we're going to do is build our little API. So from Flask, we're going to import capital F Flask request and JSONify. The next thing we're going to do, cores. What's cores? I don't know what that is, but that's curious. I'm always curious whenever it suggests things that I've never heard of. Comment below if you know what cores is. Anyways, from transformers, we're going to import those two things. Yeesh. We're going to import Torch, and it just knows we're going to import OS. It knows we're going to define our app for Flask app. If this then sets my GPU, I'm going to lose my mind. I didn't, but it's okay. We're going to say os.environ. You'll at least get that part right. Thank you, sir. We do want that model name. That's good. And in fact, tokenizer, good. Model, yes. Model half CUDA, cool. We'll take it. Very good. I'm just going to do that because you guys can just copy and paste that if you want. So now what we want to do to make an API with Flask, it's actually unbelievably simple. We're going to define our root, app root. I personally had used generate, so I'm going to keep it as generate just to keep everything the same as it always has been for me. And so that is our app root. Then we're going to define generate. And in fact, let me make that a little bigger. We'll define generate. And then we're going to say content equals request.json. And then we are going to say the input to this model is going to be content. Man, I remember asking why, if there's any difference here. But anyways, context.get. And we're going to get text. And the default will be just an empty string if someone does a post request with nothing. Then input IDs, tokenizer, encode, input, return tensors, yes. Throw it to CUDA only if you're using GPU. So if you're using CPU and RAM, don't do that .CUDA part. Very good. And now actually I'm not going to retype this same line. I'm going to copy and paste. Boop, copy. And then I'm going to come down here, paste, fix our tab issue. So again, with the automatic mix precision auto casting, we are going to generate. We're going to allow a max length. And in our case, since this is going to be API, we're going to actually set that to 2048. We'll talk about a little bit more about that in a moment. But everything else looks good. So then what we'll do is we will say, decoded equals, and actually we probably, I think that actually gets auto sent. In that case, it would actually automatically go to your CPU after this context. And like as soon as you try to do the decode and then return it, I think that would go probably automatic back to the CPU. So anyways, continuing on. Decoded, and then what we're going to do is return. That's kind of like, if there's ever problems with Python, these are like the common problems. Like sometimes it's like too simple, and like this might not actually be required in all cases, you know? Anyways, we can test that later if I remember to. Anyway, so basically, if you access this URL on our little API and you post a JSON with a key of text and the value is that text, you will get your, that will be your like input to the model. And then it's going to generate a continuation of that sequence. Let me make sure it didn't, where's that, skip special, yeah, false, cool. It will then decode that, and then it's going to return, again, text and that decoded output. So, cool. So once you have that, we are going to just need to run it. So if name equals main, yes, app.run, and in our case, host will be 000, and then port 5000 is fine. So I'll go ahead and save that, and now what I'm going to do is come back over to this window that I've been using, and let's go ahead and Python 3 OpenAssistant API.py. So in my case, let me think here. I think I'm going to just, let me make this a little smaller, move it. So now effectively we have an API running on this machine. I'm going to access it from this machine, but in theory you could access this from any machine in network, and then you could even host it publicly if you wanted, and access it from anywhere in the world. So for example, you could get a VPS or something like that and host it for yourself if you don't have enough local power. But for me, I'm just going to host it locally. So now we're going to make yet another file, and this one I'm going to call, rename, and I'm going to call it chat OpenAssistant.py. And then now, whoops, I meant to say API. And now what we're going to do is write some logic around the idea of conversing essentially with our API. So we're going to do import requests, import JSON, yes. And we're going to import Colorama to just kind of give us a little bit of color. So now, that's another one. I actually don't know if we actually have to initialize Colorama. Anyway, continuing on. Server IP we will set, and in my case, that's a local IP of 10.0018. Server IP. Whew, this is getting tough. Okay, so anyway, let me pull up this. So it looks like at least so far everything worked, but if something's not going to work, it's going to first require a query. So we'll get there if it doesn't work out of the box. So first we set server IP, then we're going to set the URL to access our server, and that is, I've always wondered if Copilot can access the other files in the directory at least, and if not, if it's not in that directory, how does it? Anyways, that's good enough for me. That's exactly what we were hoping to do, and there's no way it would know this without, unless it was because I did the copy and paste. That's totally possible. Anyways, user token is equal to, we'll fill that in a moment. And in fact, at least in my previous work, I didn't have that underscore, so I won't do that. End token. Hello? End token. And in this case, I'll just leave it empty. And then assistant token equals empty. Okay. So to get that, we will grab this. So user token is prompter. End of text token is that. And then finally, assistant token is that. Okay, so now we've got our various constants set up. We're going to define prompt. Prompt will take an input. Then we're going to specify the actual data. And in this case, we could build it here, but I actually am just going to build it logically below. So we're going to say text, and then by this point, the input will have already been built. And then we're going to specify headers. In this case, we probably don't really need headers, to be honest. It's okay. We'll just take the basic headers. Now we're going to say response equals, and then request.post, URL, yes, JSON, dump, the data, and then headers, yes. So we're just going to make a post request to our API, and we will get that response, which will hopefully be a JSON object. And then if, in this case, we actually can, let's see, what was the API? So in our case, yeah, this, I want to change this. I'm going to call this generated underscore text like that. So, oh, I can't change that, can I? I guess we'd have to wait for it to, I'm going to do that. I don't really want to wait for that, but anyways, so if you make that change with me, you need to restart your API. Otherwise, that's not going to work out. So I wanted to differentiate between text and then generated text. Probably should call that input text, but it's okay. Going back down here, so we're going to get that response, and then here we will return response.json, and in this case, it will be generated underscore text. That's what we're looking for. We could theoretically hit an error on that, and I'm going to pretend that that's not possible at the moment. So and then now what we're going to do is I don't need a main function actually. So we're going to say history, and right now history is going to be empty. And then what we're going to say is while true, thank you, sir. No way that it could know possibly what I wanted. Oh my gosh. This is probably good enough. I'm gonna make it match the code that I've already written, however, because I'm gonna upload this probably just to like GitHub or something like that. So I want it to be identical. That's kind of funny though. So we will get the user from the input. We will get the input from the user. Oh my goodness. Okay. Context is now going to equal whatever the history was plus the user token, plus the input, plus the end token, plus the assistant token. Correct. So the current context is going to equal that. Then what we want to do is probably, yes, we will prompt based on that context. Then we're going to say we do want to print there. But in this case, we don't want, because the output actually is going to contain everything, including the prompt. So we're going to have to fix that. So now what we're going to do, so output equals blah, 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 blah. So then now history is going to equal that full output. So we're just going to redefine what history is. And then what we want to do is print colorama. Yeah, it's so close to what I really wanted, but not quite. So really what we want here is like just latest assistant output, and that is going to be equal to output.split assistant token. Yeah, we want the very last element, and then we actually want to skip that end token too. So split end token. Is Copilot just too good? I mean, man. Okay, now we're good. So let's go ahead and save that. It looks like my API is back up and running, and now we will open in terminal, Python 3, please work, chat. Oh, we should have had a space there. Hey there. Hey there. Howdy, what can I do for you today? So interestingly enough, we did not get split by assistant. That's what we did, right? Hold on. I thought that's what we did. Coming down here. Oh, we didn't. Okay, we built this, but then we didn't do anything with it. Cool. Okay, save that. And then let's go ahead and fix with the space there. And then we will try again. Okay. Hi there. Wait for it. Hi there. It is a pleasure to meet you. How can I help you today? I don't know. What can you do? It's a lot, apparently. So as an artificial intelligence language model, I can read and reply to emails and messages. I would not let OpenAssistant do that for you. Generate text on various topics. Yeah, probably. Perform online tasks, such as web searches. Nope, can't do that. Okay. Can you show me some basic matplotlib code? Apparently, this is a lot of matplotlib code. There we go. Okay, so you got some basic matplotlib, and then that's oh, it did make it. Can you show me a line graph instead? So you get the idea. It's already a pretty decent chat app just with those things done. And then now every time we want to just make any modification or build another piece of software that interacts with this specific model, we can do that. Now, we only have one slight problem. The problem is if this conversation goes on long enough, what's going to happen is we're going to have a context window, context that is just too big. So the maximum size that this model can take is 2048 tokens. Now, 2048 tokens is a lot of tokens, but if you just keep going on this context or in this chat, you are going to hit it. So what we can do to kind of handle for that, and I think probably round off this specific video, it's getting quite long, is to add a little bit of a cushion, basically, to always allow for, because basically the context, so the history has to be less than 2048, but you also need to account for, well, how long might the model's response be? So in general, like 128 is probably comfy, 256 is like very comfy, and then 512 would be like extremely comfortable. Like it would be a surprise if the model generated 512 tokens of a response, but I suppose it's plausible. But also, it's unlikely that you're going to need a history much bigger than 2048 anyways. So what I'm going to do now is we'll break that. I'm going to start that fresh anyways. I'm also going to break the API, and that is where we're going to make this change. You could make this change at the assistant level, and it might make sense to make this change at that level, or at the chat level rather. And it might make sense to do it at that level, but there's a bunch of different ways that you could handle for something like this. So another option is, as the context approaches, let's say 1,500 tokens, you might instead use that language model that you're using right now to actually summarize the history, try to condense it down, and then now that becomes the new one. And then you just keep doing that. You just keep summarizing down the context. And I think you could probably do that with some success, depending on what kind of application you're actually building here with this chat model. But anyways, what we're going to do is something a little more basic, and we're going to do it at the API level, and all we're going to do is just trim the context if it's too big. So first what we're going to do is we'll just come up to our constants here, and we're going to say max context length, and this will be dependent on the actual model. The answer is 2048, but I kind of want this API to be usable for different models. So in my case, I'm going to say model.config.maxPosition embeddings. I'm actually not sure why it's -2. Is that for the special tokens probably? I don't know. Why would it default to that? But anyway, this will be 2048. I'm not sure why it says -2. It's got to be for like as like special tokens. I don't know. Someone comment again below if I'm wrong on that. But anyways, let's just go ahead and make a print really quick. Max context length. Cool. I just want to see what it is. Make sure we got that right. And then we're going to say room for response. So how much of a cushion do we want to leave for a response? And in my case, I'm going to say 512. So now that we have those values, the next thing that we want to do is we're going to come down. Oh my gosh, we're in the chat. Okay, cut that. Nice. Coming over to API now. Coming back up here. Coming over here. Pasting that there. Now what we want to do is we're going to come to basically here at the encoding process. And this is partly why I wanted to just put it in here, because this is already going to have the tokenizer loaded. You could take a guess at how many tokens a string is based on how many characters that string is. But in general, tokens are going to be multiple characters. So if you just want to be perfect, this is the way to do it, probably. But we could also, you could load the tokenizer. The tokenizer is like very lightweight to load and use. But anyways, coming over here, input IDs, blah, 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 tokenizer, encode. So once we have that, what we're going to want to say is we'll say print, and then we're going to say the context length is currently, hello, give me that back. Input IDs dot shape 1, yes, that's correct. Tokens, that's fine. We can leave that. So again, it's going to actually be at that like first index. So keep that in mind for the next few lines that we're going to write. So this tells us where we are, and then if we needed to trim it, what we're going to say is just add a bit of logic, and we're just going to say if input IDs dot shape at the firstth is greater than max context length minus room for response. Cool. And I'm actually going to take the suggestion here because that's fine. And the only thing I'm going to do is I'm going to add some parentheses here. This shouldn't be required, but it just always makes me nervous. Okay, so context length is too long. Truncating, yes. And in this case, we are just simply trimming at the firstth element here. And we're just going to say we want everything from the negative context length plus whatever room for response we want to make, and then everything from that point forward. So now minus blah blah blah. Yeah, and once again I'm just going to do this, and that should allow for us to just infinitely converse with this. Oh shoot, actually. I think we could probably do that on the GPU, but I'm not positive. So I'm going to cut the CUDA part, and then we're going to send it here to the GPU. Okay, so I'm going to save that. I'm going to restart the API, get that running, put that back up here. Oops, model is not defined yet. Let's just move that. Cutting that to here. So I got an error that said the model is not defined, and we were just trying to access model before we had actually defined it. So saving that again and restarting the API. Okay, looks like our server is up. So let me make a window bigger here. And Python 3 chat. Hey, how's it going? Yo, just getting through another day. How about you? Big chillin'. Good, you? I knew we would eventually get there as this conversation became more informal. With no awareness of my activities, I'm unable to answer that question. Good luck with your day. Okay. Anyway, that's good enough for now. As you can see, it's a pretty good model. There's a little bit of this as an AI language models nonsense. The good news is if you want it to do things that normally you'd get this type of response from, say, ChatGPT, you can use prompting to get around this and kind of hack your way into the sort of behavior that you're after. So I definitely suggest that you play around with this model. It's a pretty powerful model for being only 12 billion parameters. And like I said too at the beginning, it's constantly under development, and there's so many open source models coming out right now. I do like what OpenAssistant has been doing, especially open sourcing like their data set, the training of that, like everything is open source. So I really like what they're doing there. So definitely keep an eye out for what they're up to and all that, and some of the models that they're coming out with. They do have some of the other like llama based models. I'm opting to like not touch the llama models purely because the license just doesn't seem to make much sense to me for use. Also, those models like weren't even supposed to be out, so it's a little unclear like what can you really truly do. You can play with those models, but what can you actually do with those models, and how can you use those models is kind of unclear. And with that in mind, it doesn't seem to me like a good idea to spend a whole bunch of time getting good at working with those models or building anything off of them. So anyways, I think that's all for now. If you've got questions, comments, concerns, whatever, feel free to leave them below. Otherwise, I will see you guys in another video.